In this video, we'll learn how to use Excel to find the confidence interval for the mean when the population standard deviation sigma is given. When the population standard deviation sigma is known or given, we use the z distribution. But in reality, we rarely know the values of the population standard deviation. If the sigma is not given, then we have to use the student t distribution instead of the z distribution. Confidence intervals can be constructed in Excel using the XLS stat or the megastat add-in, but we will use a manual procedure in this tutorial. Recall that the lower bound for the confidence interval is found by getting the mean minus the sample mean minus the margin of error, or x bar is the sample mean minus the margin of error, which is the z of alpha over 2, the critical value, and multiplied by sigma, which is the population standard deviation, divided by the square root of n, and n is the sample size. For the upper bound, we just change the minus to the plus. Okay, looking at the procedures, we know that we have the alpha over 2 on the left and alpha over 2 on the right. Together, they are 1 alpha, which is the significant level. And the middle region has the 1 minus alpha, because 1 is the entire area under the curve. If we have alpha half here, so they are all together is 1 alpha. So the rest of the area in the middle should be 1, which is everything minus the 2 tails here, which is alpha. Okay, so looking at the formula, we need to find the sample mean x bar. This is just the mean, the regular mean or the arithmetic mean. We can do that by using the average function, right, to find the mean. And then for the margin of error, we will use the function confidence.norm. Okay, this is the confidence.norm function to find the margin of error. Now this function takes in 3 inputs: the alpha, which is the significant level, sigma, the population standard deviation, and n, which is the sample size. And for the left critical value, which is minus z alpha over 2, we can use the inverse norm function, right? Norm.s, s is the standard normal distribution. So norm.s.inverse or inv, and we input the alpha half, the left area. And then for the right critical value, once we know the left area, the left critical value, then we just change the size to get to the right critical values, because they are symmetric, right? They are just different in the size. One is plus, the other one is minus. But if n is less than or equal to 30, we will need to check to make sure the sample is coming from a normally distributed population. Otherwise, we need to use the bootstrapping methods or non-parametric methods. Okay, let's move on to another topic, finding the confidence interval for the mean, but this time sigma is not given. Sigma is not given, which is the population standard deviation is not known. Now, if that is the case, we use the t distribution instead of the z distribution. Remember, if sigma is not given, we use the t distribution. If sigma is given, we use the z in the last section. Again, Excel has the built-in program XLS stats or the mega stats, but we will use a manual procedure in this tutorial again. Now for the lower bound, we get the mean, the sample mean minus the margin of error. And for the upper bound, we use the mean plus the margin of error. The formula is very similar to the last section, except the z now is t alpha over 2, and then instead of the sigma, now we use the sample standard deviation, the small s. Again, the procedures are the same. We have alpha half on the left and then also on the right, and then therefore the middle area would be 1 minus alpha. To find the sample mean, we use the average function, right, to find the sample mean. To find the sample standard deviation, we use the stdev.s function. This is the sample standard deviation, and we input the data in to get the value of s. And then find the margin of error, we use the confidence.t. This is the student t distribution, so we use confidence.t. In the last section, we use the confidence.norm because this is the z distribution. So again, the margin of error function, it takes in 3 inputs: the alpha, which is the significant level, and then the s, sample standard deviation, and the n. In the last case, we use the sigma, but now we don't have sigma, so we use the sample standard deviation s and the sample size n. And then for the left critical value, we just use the inverse t instead of inverse norm. So t.inv, and we input the left area, which is alpha over 2. But there's one more extra argument here, which is the degree of freedom n minus 1. And then for the right critical value, it is the same thing as the left critical value, but then we take the minus, the opposite side of that, because they are symmetric. Alright, and similarly, if n is less than or equal to 30, we need to make sure to check the sample to make sure that it is coming from a normally distributed population. Otherwise, we need to use the bootstrapping methods or a non-parametric methods to find the confidence interval. Okay, let's take a look at one example. In this case, we want to construct an 80% confidence interval for the mean of the below data, assuming the value is taken from a normally distributed population. So we are given the fact that these data, they are coming from a normally distributed population. And even though it is only 15, right, which is less than 30, but the problem assumes that it is okay to use the assume that the sample is drawn from a normally distributed population, so we can use all the methods we just discussed. Now, because we don't know anything about the population standard deviation sigma, that's why we need to use the t distribution instead of the z distribution. And then we are given the fact that we need to construct an 80% confidence interval. 80% confidence interval, that means your alpha is the order 20% or 0.2, right? 20%. And if that is the case, then your alpha half is 0.1. Now, the first step is I need to enter everything, all the values in one column. After I enter all the value in one column, I need to find a sample mean, right? I need to find a sample mean x bar because we need that in our formula. Our formula say to find the lower bound or the upper bound, we need the x bar and then minus the margin of error. So we need to find that x bar or the sample mean, right? Or let's just say x bar. So to find x bar, I press equal and I use the average function. That is the mean. So I drag off the value, I close it. So my mean is 80.37. Now I need to find the S value, the sample standard deviation, right? Sample standard deviation, because I need that as well. So let me just put the sample STD, standard deviation, the small s, or let's just put s. Now that's one I use the function stdev.s to find the sample standard deviation, and then I drag everything inside the list here and then hit enter. So this is my x bar, this is my s that I need in the formula. And then now to find the margin of error, you use the confidence.t. This is the t distribution, not the z. So we use the confidence.t, right? So this is margin of error. You can expand the column. All right. So margin of error, I put equal confidence.t. And then the first argument I need would be the alpha. Alpha is 20% or 0.2, right? 0.2. And then the second argument I need here, you can see the formula down here. Standard deviation, that is the S value. The S value, which is the one I just filed up here. So I click on that, and then comma, the sample size. We have 15 of them. So I input 15 and I close everything. So my margin of error is 3.01. And now I have everything. So I can find the lower bound and my upper bound. Remember, the lower bound is equal to the sample mean or x bar minus the margin of error. And then my upper bound is equal to the mean or x bar plus the margin of error. So you just add it and press equal. And here is my confidence interval using Excel. So you just have to find the x bar, sample standard deviation, the margin of error using the confidence.t function. And then after that, you just apply the formula, the sample mean, subtract the margin of error to get the lower bound, or the sample mean plus the margin of error to get to the upper bound. And here is a quick review of all the functions that we can use between the z distribution and the t distribution. We use the confidence.norm for the margin of error for the z, and we use the confidence.t for the t distribution. Remember, we need to input the three arguments here: the alpha level, standard deviation, and the sample size. And then for the left critical value, we use the norm.s.inv alpha half, and then t.inv alpha half for the t distribution. And don't forget the degree of freedom. And then for the right critical value, we just put the negative value to the left critical value because they are symmetric, right? For the z and the t distribution, they are symmetric. So the left and the right critical value, they just have the opposite side. And then for, remember, the lower bound, we just highlight the mean and we subtract, we just highlight the margin of error. And then we just add them if we want to get the upper bound.